Why other student didn't come? Roy, can you please give them the hint in Dink Talk that they join also? I think still some of them are thinking that we will put something in Dink Talk.
I don't think so because like we're not much student, so everyone
No,
should
but
know.
I can see some of them are not there. I don't know. All the time, I should tell them, please come, please come. I never do that. I will start on time and uh, I will close the adding part soon. Okay. Oh, we can. You can have me and also PPT. Yes.
Yes, sir.
Okay. Good. 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 Still, there are something that I should learn from this software. I think after 1 minute, I will start the lecture. I'm just waiting for your friend. As I say, I will do some setting for this software that after some time nobody can join. Otherwise, I think it's not good that some of you will come late, some of you. Still, I have lots of problem with this timing management that you will do. Any question from last lecture? If you have any question, we can start with that. And otherwise, I think most of the students is here now, and we can start the lecture. Meanwhile, Hossein, did you send your task?
Yes, sir. I sent you that
Okay.
time.
Before starting the lecture, I should tell you that by university rule, we should use the software that we have. And in that, there is some limitation time to sending the task. If you send it on time, it will be accepted. And if you didn't send, then we cannot do anything. I changed the time from 9 to 10 in the morning. Maybe it will help you more. But the student who didn't submit their task on the web page, we cannot do really anything. And now there is no additional work for me to make the Excel sheets. Everything will go through itself and it will be monitored for the school. And I think this is the good system that they provide. Just if one more students will come, we can start today lecture.
Lashi, so the time is depend on university's authority, right?
No, actually the time is depend on me. Regularly I put 9 as we had on the PPT, but today I put it on 10.
Yeah, no. I talk about assignment submit system.
Yes, exactly that things. It's in my hand, but I should
Yeah.
specify the time. I put it 10 because in the PPT, if you read, that was 9.
Okay.
Okay. I don't want to tell you that university wants to do that. No, I put that time 9 and now I change it to 10. But more than 10 because I know your schedule. You have lecture. If you don't send it, it means that you will not send. Okay? 10 is okay for all of you?
Okay, sir.
Yes,
Okay, just aware about these rules. Well, let us start. I will close my windows. Oh, let us do the attendance also. Just hold on for 1 minute and then we will go for the attendance and then we'll start today's lecture. Okay, got it. Well, please turn off your camera. And Mala, we are in the lecture. Don't eat. Yes, Jahad also, you also please turn it off. Anyway, what we talked regarding the last lecture, that was primarily introduction about, yes, I found it, about Arduino board. And there was one point that even I tried to tell you the history of myself when I wanted to use the Arduino. I think now you should see the PPT.
Yes, sir.
Yes. Okay. I tell you one story that how I start the Arduino board. That was my story about starting to work with this nice board. But really, after some years, when I teach Arduino, I saw that this is the big challenge between all people. And even I found one nice article because still there is not as the in all embedded system there is not any thumb rule, really right side rule regarding the selecting which Arduino board is proper and which one is not proper for the embedded system developer. But a big but, there are some terms and conditions which true that, and there are some clue that after some year or maybe some months, it depends on your skill, you can select the proper board easily in Arduino Word. I found one nice article which is from the Broadcast, and the name of the book is Arduino Project for Dummies. He says some nice word about selecting the Arduino board. My story to selecting the Arduino board and initial board was that we just had three board. One was Dewey, Ono, and Mega. And I, because Mega was in the medium range, I mean, not very cheap like Ono and not very expensive like Dewey, I select the Mega. And by chance, I tell you that that was the right correction and right selection. But truly speaking, this is not any place in the engineering board or any embedded system board. It's selecting like this randomly. But I have done that, and by chance that was correct. But today I want to tell you some method and some way which may guide you to do it better and have some scientific selection in Arduino. You know, Arduino project has come a long way in only a few years. It started out with just some single simple boards that offered basic feature, and mainly as in history they say that that board didn't use the USB because maybe you know the first Arduino board introduced in 2005, and in that period of time few computers or few laptops use more USB as today. That times there was more serial ports. Uh, and nowadays you can find over the dozen of Arduino board, and each with its own unique characters and features. And the current full listing of Arduino product is available on Arduino website. It's my suggestion for all of you that please visit the arduino.cc. Even today I will teach you, and you have one assignment that how to install the IDE of Arduino on your PC or computer. But visiting this web page also will give you lots of knowledge. Mainly, I don't think that you expect that all the time I will be update for that. Even I will try, but it's good for you to see that web page. In this web page, they listed all the Arduino boards that today also we will see again, but based on your requirement, you can select. Let us have one round, one tour regarding the Arduino boards, but from the point of view or the points that Brock Graff in his book will say. He say about Arduino Uno as the main workhorse in Arduino family, and it's based on Atmega 328 microcontroller with the crystal, which is operate on 16 megahertz. Nice thing in Ono is that it has 14 digital input output pins and 6 analog pins. Power can be provided by USB as well as DC barrel connector, or by using power into header pins. My friend, something that I should tell you for the Arduino board, try to little bit avoid this part, which they will specify on VIN or VIN on the board. But if you didn't have any option, you can do. But main things or main part that I think is safer side for the input entry, especially for the voltage, is that using that DC barrier, because in that you have the regulator and some filter which will give the better and correct and stable voltage to the microcontroller. We have onboard power regulator, which is smart enough to know which one is being used, and it has some handy onboard utility LED, which, as I tell you, it's something like contract between all Arduino boards, and it's connected to pin number 13. And the reset button. A key difference of Ono from all previous boards is that it has the USB controller chip, which is integrated on the board. And this feature make it easier to hit the ground running because you simply plug it into your computer and run it. Maybe some of you, if you search, and maybe some of you will ask me, is there any board which didn't have this feature? Yes, some boards like Micro and Mimo, there were the boards that you should use some FTDI programmer, which exactly that is that USB controllers IC, and you should interface your microcontroller with the help of that FTDI board. The next board, which it's interesting between the embedded developer Arduino worker, we can call this group of people, which I'm also among them. It's Arduino Mega, which this board will use the Mega 2560. We can say it's Ono's big brother. Really, it's big brother, and it has the lots of nice feature. That was exactly the board that I select randomly. And nice thing is this board, in Mega, is that 54 digital IO pin, fantastic. It has a PWM board, PWM pins, which later I will teach you. I think after 2-3 lecture, I will tell you what is PWM. This PWM in Mega will start from pin number 2 to pin number 30, and rest of the pin till pin number 54 are digital pin. Again, we have that contract. We connect the LED part to the pin number 30, and we can use the control and sensors interfacing through this nice board. I personally like Mega, and this is the secret, but I tell you that most of the board which I developed since last 4 years back till today, I try to use the Mega. Let's read about the next Arduino nice board, which name is Leonardo. Leonardo is again similar to Ono. And as I tell you, Ono means one, because this is the, we can say, grand generation for the Arduino, or maybe the pioneer generation for the Arduino board. But it has more IOs, means that around 20 pins for digitals and 12 pin for the analog. It's also great, but it's really stand apart, and is that it has the second serial ports, 2 serial port, nice. It can use the do some nifty tricks like emulating the keyboard and a mouse. Something that I forget to tell you about Mega. In Mega, we have 4 serial ports. Fantastic. Then next nice board is Lilipad, and as you remember, I tell you that this board is good for girls. Maybe Mala in the our lectures can use it, because we don't have that much skill. Uh, this board is um, mainly used for clothing and textile jobs, but as you will see, it's running on 8 megahertz. Compare with Ono. Ono is 60 megahertz. Compare with Mega. Mega is 60 megahertz. Compare with Leonard. Leonard is also, I think, 6 megahertz. But Lilipad is 8 megahertz. Means that it's little bit slowly than other. Arduino Micro is super crap and perfect for tight space. When you have small space on your board, it's the perfect choice for you to use it. And what nice thing they have done, they use the micro USB connector. Nice thing is that you have 20 digital input output pin, and it has no pin header. So you solder the connector directly to that, and you can mount it there. I remember the first project that I finished with Arduino, some commercial one. I used the micro, and I'm very happy that since these 5 years, that project is working. And even if it's fail, I don't know that what will happen, how they will find me. But now, still, I have good news that till today it's working. Till tomorrow, I don't know. And next board is Dewey. Dewey is very nice. Especially, I think that Arduino company needs some ARM processor like SAM 3X8E. But something is notable about this board is that it's using 84 megahertz crystal, 54 digital ports. See, 54 digital pins for Dewey, 54 digital pins for Mega. But speed here is 84, speed there is 60. It's more robust and use 3.3 volts on board. Fantastic. And but in Mega that is 5 volt. No? So we should avoid it for the some project which they use the 5. Then this board I bring them here. This is Ono at top, Mega, Dewey, Mini, and Lilipad. And this is Leonard. Okay. Let us do some comparison between this 1, 2, 3, 4, 5, 6 boards, and see that along with suppose some internal feature that we have inside this board, what else we can touch? Nice thing in our Arduino board is IDE. Means that the program that are written with the ONO can load on DOI. Just remember one thing. You know that the number of digital pins in ONO is 13, but now here we have 54. It means that if I'm in my program, I mentioned the pin number 54 and I use the ONO, I have error in my IDE. But if you use up to the limitation of the ONO, simply you can use these other boards also. Uh, Then the older Arduino you may encounter are Similia, Dewey Milinav, NG, and Bluetooth. That these we call it older one, and nowadays they it's going out of stock. Be aware that Arduino IDE has changed a bit as hardware also have evaluated, and not all older boards will work with IDE. Some trick that I tell you that sometimes uh, I had problem with loading some big program with recent IDE. Then I come back to IDE 1. Now we are in IDE, I think 20, something like that. And then that was work. This is one practical point. At proper time, I will tell you why we should do that. But remember it or keep it in your mind. And remember that some software library also update along with the IDE's board name. Some libraries also update that maybe uh, it helps for the developer to use better. This is the 2020 Arduino board that you can find them in a table and you can compare about three things. One is that the voltage consumption. The next is the speed. And obviously the various controller that they use. But suppose some nice thing is there. See here, Arduino Poro, which gone. Now we have Poro Mini. See, in Poro Mini we use Atmega 168. With two different crystals. Means that when you will buy, you should ask or you should find the uh, some specification from the seller that which crystal you use. Okay, even you can see from that. Suppose you see that we have three generation or four generation for Lilliput. Lilliput USB, Lilliput Simple, Uniswap, Simple Snap. All are in linear Go, or even Mega. There was two, ADK and 2560. Now 2560 is little bit gone, and people prefer to use the ADK one. These are some nice table. More than this, you have on Arduino .cce web page, and you can select. But fixed question that we have: which Arduino board is proper for me? It's depend on some factors. The main factor that I can tell you is that the speed is first. Second is that size. Third thing is that number of the digital I/O pin and analog I/O pin that you need. Main point, more than all this, is that working voltage that you want to work. And the next thing, which I can tell you, even it's more than voltage, working voltage, it's important point, is that the cost of the board. I think that you are agree that when you have 54 pin like Mega, you should not have the same price like Ono. Or if you have the small size like Micro, you should not have the same price like Ono. And if you have LilyPad, your price should not be like Ono. But remember, LilyPad is more expensive than Ono. Okay? Keep it in your mind that sometimes it also will happen, some special design, even they use the less material, but again, they are expensive. Okay? Remember this point that I tell you. Meanwhile, of our lectures, again, we will talk regarding how to select the proper Arduino board. As we are working with the Ono, let us review it once more, or see the Ono from very nearest look. Okay. If you see at the top, pin number 0, till pin number 13, it's written digital. And the nice thing is that they put in parentheses PWM and put this icon. And this icon is just for some limited pins, something like pin number 3, pin number 5, 6, 10, 11. It means that just these pins are capable to provide the PWM for you, and rest of the pin are not. Remember it, we need. Then you will see one ground here, one AREF, which is used for the analog pin. And analog pins from A0 to A5 are seated at the downside of the board, reset switch meanwhile, and 5 volt, 3.3, ground. VIN is exactly that pin. You know, when you want to connect your Arduino, you have 3 ways. One is USB, which is voltage is fixed. It can use for programming or giving the voltage. You have 7 to 12 volts that I tell you that please use not more than 9 volts, okay, for your safety side. And this is also one pin, VIN, and one of these ground, it will help you to run the boards from this part. And some funny things I saw. Some of Arduino boards ground are not connect together, these two ground. Sometimes remember that you should connect them together to run. But that was maybe the board was faulty, but I was surprised when I see that these two ground are not connected together. Even with the Mega also, I saw 2-3 times that same happen. Okay, remember that. Then if I want to run my system, one adapter or one 9 volt voltage is perfect. It can run it, and the voltage, analog pin, reset, and serial transferring pins also mentioned in this figure. Next question is that, okay, that was Ono, we go and buy. What about IDE? What we should do? For IDE, it's very simple. Just you should enter the arduino.cc, go to software, and download parts you select. And from download, just try to select the download installer for Windows XP and up. This option or Windows zip. I advise you to install the Windows zip file because you can install it better. And then the next page which come, and you will say that I don't want to pay without any donation to the zip file. It means that after you select or press this part, the download page will come, and you can easily download and finish. Then after doing that, you can easily enter to the Arduino board. Let us see one example after installation. That what we should do, you should first write your sketch, press the compiler, upload, and see that your board is blinking. Very simple things. After you install the IDE, you may have some similar windows like this, because I run this in Linux. The interface is different, but I have some purposeful. I bring it here to tell you that we can run it even on the Linux, but uh, and the ports are same. But I have some photo about the Windows also IDE, which we will see. There is some nice part or some specific important part on this IDE. This is the Arduino IDE after you install it. We have one clip that you will see better, but let us finish this part and after that see the clip. The first button, which is something like play, it's compile. And beside that, we have some part that we call it upload, means the next one is upload. In this version upload, they put it here, okay? We have one part that we call it serial monitoring. We have one white page, which we call it code editor, as well as we have some text output, serial, which will say, and some more data. What is that data? It's something like this. It can give you which board you connect and which serial board you select at the time. Here in this black part, it will correct your program and will give you the response. Is there any error on your program or no? If yes, you will see here. If no, you will see the word done compiling, something like that. Let us see the word. This part we call it code area. This part we call it info panel, which shows any error. This part we call it verifying, which allows you to compile. Upload, which this mark, and serial monitoring, which after you press this part, the small windows will come, and you can see the result. That's it. ID is this much simple. And one more thing that even last lecture I tell you, some important function you need. These four important functions are all the functions that you need to work with Arduino. For example, serial.println value. It's going to print the value for you with the help of serial communication. Or pin mode is something like that. Based on that, you will define that your pin is input or output. If pin is input, you will specify input. If output, means that it should turn on the LED, something like that, you can put it output. Digital write pin that generally will use to check the state of the button, and it has two states. One is that high, one is low, and then it can be in high or it can be low. Next is digital write. Whenever you want to turn on or turn off any LED, means that you want to make that pin high or you want to make that pin low, you can use this statement. In my idea, all the Arduino language is this part. Rest of them I teach you in C language. Let us see two common problems from the Arduino user that you also may interface that. First is that the name of the board should be correct. Second is that the port which is connected. Somehow, suppose you are using the USB hub to do your job. My advice is that never use that pin for Arduino. Use another pin with the USB out and put one specific USB part for Arduino. Then with that, you can find that which COM port you should here select. Last week, one of the Arduino active persons sent me this photo, and then I share it now with you. He said that if we want to do the serial monitoring, we can Control Shift plus M for the PC, and for Mac, CMD plus Shift plus M will work. And here, what he said that another problem is that the speed of serial should be as we will select here. For this part, I have proper lectures. Then no need to memorize it, but it's not a bad idea to have this shortcut, Control Shift plus M in your mind. Okay, we run the IDE, we install the IDE, then how we should run our program. Suppose any program has this step. We will write the code, compile the code with this. After compiling the code, we will check the port connection and also name, and then upload the code, and Arduino and connected circuit will start to behave based on the code that we have. Some students tell me that, is Arduino simpler than other AVR microcontroller? I say yes. They said, okay, show us how. This slide, exactly I prepare for that student. On the right side and left side, you will see the same program which I written, one for Arduino and another one I written for AVR. In the both program, what you should do that, you are going to turn on and off the LED number 13. And based on that, I returned the code. But see the number of lines from AVR and number of lines in Arduino. Even, I don't know, you remember when we reviewed the C course, we said that the new generation of the language are going to be more linguistic and will become more near to what we thought. Is it not like Arduino language? Suppose I say pin mode. I want to say what is the mode of my pin. My pin is output. And which pin? Pin number 13. Okay, setup person. And for the loop, what should I do? I should write or make the pin number 13 high, and I should use the digital right. When I want to make it low or turn it 0, simply I can use the digital right statement. Okay, between these two, I need some delay. Then 1000 is equal to 1 second. It's okay, we can use. Same in the AVR also, I have done the same, but here we have some register that we should know which pin first select, and then with the delay again turn off the push. Then you will see that somehow Arduino programming is simpler than AVR. And even I don't accept this word that people say that this language is simple, that one is not. But I think Arduino is simple, and coding is much more near to the linguistic language that we have. Okay, let us see one movie or one clips that I will tell you how to download the IDE. And this is your assignment. You should do it and run it on your system. Okay. Simply go to Google, to the arduino.cc, enter. Then select the Arduino home. Wait till the time they open the Arduino page. Yes. Then simply you can go to the download part. And you see that there is lots of parts. From the software, go to download. Then, yes, between the, you will see Windows zip file for non-admin install. For Linux person also, they can install the new Linux version. If you do that, if you want to spend money, do this. If you don't want, okay, say that just download. The software will come and you will see the download process at the top. Nice. The ID is download. Now, next step, after it's download, you should extract it, extract. And after this extract phase, you should do the exe file or exe file to run it. Okay, it's unzip. Take this exe file or running file and just press. Okay, the ID page is open. You can see the various parts on that. Let us review. Suppose for the file part, it has something like, let me stop it. New, if you want to open the new project. Open, if you want to open the previous project that you have. Open recent. Examples, which is very important. Close, save, save as, so on. Then for the edit, copy for from, paste, select all, scratch, and then tools, which is most important for us, and help. The preference for parts part you can go, you can change the language. You can make it in Persian, you can make it in Bengali, you can make it in, I don't know, English, Chinese, whatever you want. And then after that, you can do the programming part, very simple, with the help of Arduino. Okay. Till now, what we touched that mainly we review the Ono, we review some other Arduino, and I teach you how to download the ID. Your task for the next lecture is that you should download and install it on your computer. No need to send me anything about this task. Maybe for the next lecture we have some tasks, but you should install it on your computer. That from next lecture or from this lecture, I want that you also replicate my work, whatever I share on the PPTs, and see that what you will do. Is there any question from a student side? Just 1 minute. Maybe I made you all mute. If let me see. Yeah. Okay. Is there any question from a student side?
No, none from me, sir.
Any others? Fast.
No, sir.
Okay. Then I think that because next part is little bit lengthy and we should talk more, please permit me to start that and save our time that we should finish this C language part also today. Agree to continue?
Sir, definitely, sir.
Yes, sir.
Okay. Kaya, I know that always you are agree, but others I don't know.
Yes, sir.
Okay.
No problem.
No problem, Faisal.
No
Can you
problem, sir.
start? Okay, let's go. Let's
Yes,
go.
sir.
Let's go.
Okay, sir.
Good, good. I think now today number of sleepy students are less. I can see that. The next talk that we have today is regarding all the function or all the statement and syntax that we can use on Arduino. Uh, nice thing in Arduino is that Arduino is relied based on C language. And as we know C language, there is no need to review all. And another nice thing in Arduino is that everything is in open source mode. Then my first comment is that don't afraid of Arduino because you have two, three tools to review. One is that it's an open source. Then okay, go ahead. Whatever question that you have about Arduino, simply you can uh, learn it from net. Second is that if you have problem with that, even means that suppose in one to I don't know some 1%, 2% if you have some question and you cannot find the answer, then no problem. You can rely on your C language text and simply replicate that work and finish the problem that you have. But there is little bit different between the C and C that we use in Arduino, which is that this C language is much more simpler than traditional C that we expected or we learned. Let us see what we have. Okay. Before that, I want to remind you one more point. My friend, any code in Arduino had two parts. Part number one is setup, which mainly you will specify the rule and mood of the pins that you want to start. Something like this. You'd say that this pin have which task. Specify the task. You specify the mood for the pin, and you tell the Arduino that what I want this pin do. This job will specify exactly in the setup part. Okay. I have one example. If you see pin mode 9 output, it means that pin number 9 I want to act as output, and I specify the mode of that here. Can it be another number? Yes. Just specify the uh, pin number that you like. You put pin number 10, you put pin number 11, 12, as you want. And then you can specify it as output. Can I change it to input? Yes, I will teach you later, but now you can also put it. One nice thing, or maybe difficult things for some person in Arduino is that if you see this output is in cap, just you should remember that if the Arduino syntax is in cap or some in cap, some in small, you should replicate exactly the same. You should not, you should not write it with, I don't know, some part cap, some part small. Uh, and definitely if you do that, you will have some error from compile. Let us review what I said. Setup section is used for assigning the inputs and output. Suppose motors, LEDs, sensors as input and output. And it also specifies whether device is output and input. To do this, we will use the command pin mode. Suppose here as the example. What about next part? Next part is loop. Which in that, if I want to repeat the work, I should use the loop section. Suppose what I have done here, I make the digital pin number 9 high, put some delay, then put digital pin number 9 low. Again, put some delay for that. And you will see that the pin number is specified here, and um, turn it on and off by high and low will happen. And that 1000 in the delay library, it means equal to 1 second or 1000 millisecond. About this delay, we have some talk in, I think, after 2-3 lectures. And when I touch the timer part, and we'll tell you some critical point about them. That was the main structure of Arduino language. But how we should define the variables, how we should define the parameters, how we should use the function, these are some that we will see today in this lecture. You know that in C language, the important aspect is that it can stores the data. And data type, something that we will discuss here, can be integer, can be float, can be characters, and so on, which we are going to talk. Suppose if it will be character, I will use the char to say integer, I use int. Float, float. Double, side, unsigned, long, and short. It's exactly like the C that we have in our C language part. Okay, go ahead. Suppose about the data types, which data types I have. I know that bit I have, character which has 8, and you will see the range, short int, long int, float, double, and bool. Okay, these are the type of the data that I have. Then don't remember, variables can be char, integer, float, double, but data type can be bit, char, int, short int, float, double, and bool. This is, please, you remember. Then I know the variable, but how I should declarate them? Variable can be declared inside the function or outside of them, and they can show like this. You know, we can say type of them and name of the variable. Suppose integer and then name of that. Global variables are declared outside of the function and are visible from the end of the declaration to the end of the file. And local ones are inside, and it's visible only from the end to end of declaration to the end of the function. It means the same rule that we have in C language still exists for the Arduino part also. What should I do if I want to assign some numbers to variables? Simple. Variable name and then the value that you want. Suppose I have variable which you call it count, and I want to assign the value of 100 to that. Simply I will do x, which we have the int x, and we want to give it 10. Float pi, which we want to give it or assume it as the value of 3.14, and simply we can do that. We have one more way that we call it type def, which used to create a new name for an existing type that rarely we will use that, but anyway, you can use. Suppose type def sign char small int, like that you can define the variables. Suppose type of some short my int or int my int, something like that, which can be specified between the 8-bit for 8-bit processor or 16-bit for 16-bit processor. These jobs will help you if your code contains many variables and will use to hold a count of some sort. But whenever some other person also reading your codes, they would recognize that any variable declared as counter is used as a counter in the program or as another jobs that you assign for them. But let me tell you one critical point before I stop for first part, is that try to use the word which are not famous or recognized by the IDE in another word. Suppose this word counter will make the IDE confused. Try to use some new name which not have the conflict with the IDE understanding. Okay, let us have some rest, and again we come back to continue for today's lecture. Before that, please turn on your camera that we do the attendance, and then fast we will take rest and come back. Fast. Okay, let me see who is remain.
Sir, my camera isn't working, so I'm present.
Yes. Okay, wait. You can turn it off, and let us continue our lecture with the variable assignment and variable declaration. We can say, you know that in any programming, the first node that you will start is that you will define the variable. You will say that, okay, I have which member I have in my program. It's equal to the this concept that suppose which tools I have and I want to use them inside my program. Or in other words, means that which part I have for this puzzle of my programming and which type they are. Suppose you know that I can have different variables. One could be character, one could be the integer, one could be the float with different precision. Okay, and then each suppose these variables can have some different values. One is 100, 200, 300, like that. This is the initial gate for any programming language. In Arduino also we have when we want especially to work with the program which in that you have variables, you should assign and you should also declare the form and value of your variables. And mainly we have this type, suppose type and value like this: int val 16 bit, long val 32 bits, val in something like that. You can have short integer, long integer, but I should tell you, in the state that you are, in the program that you are, rarely you will use the short integer or long integer declaration. I didn't say that it never, but I can tell you that in the stage that you are, and maybe I can tell you till these 10 years when I worked with Arduino, I just use in 2, 3 projects long and short integer. Rest of the time, integer is okay and int will work. Then don't make yourself confused with using now I should use short integer or long integer and so on. Okay? Keep it in your mind. We have something like auto, which specify and indicate the memory location of variable, which is temporary, and auto is default for function block variables. We teach this in the C language, and I can tell you again, rarely you will use in Arduino. Extern also is one more, which is the variable which is defined somewhere else and useful when splitting the software into the multiple file. Can have some sample like this. Suppose in int farvar, in use.c, we use the extern int farvar and int a and something like that. Rarely you will use them, but somehow if you need, you can use them in Arduino. Again, variable storage class also we can use in the static one, something like a variable which is stored in the static memory and is returned the previous value on the reentry to the block code. So it's eat up your memory, and its example, the variable count in initialize once and thereafter increment every time the function test is called. And then the register, which is used to define the local variable that should be stored in the register instead of RAM, means that the variable should be stored in the process register, and register should only be used for variable that require the quick access. Remember, the point that I will tell you for this C language, before you pass that course and you know it, but just we want to polish your C skill, C language skill for today especially. I should go a little bit fast, that we can just cover, and you see that there is no difference between C language and Arduino language that we are going to uh, do the programming for rest of our course. Next thing that you should do when you do any language or any programming language is operators. Operators is a symbol that tells the compiler to perform the specific mathematical or logical function. And C language is rich in that because we have arithmetic operator, comparison operator, Boolean operator, bitwise, and compound. I can tell you this part is very important because you can do very nice job in the uh, Arduino um, programming with the help of an Arduino programming language. Suppose operator. You know that we have equal, we have plus or add, we have subtract, we have multiply, we have divide and modules. Same as C language, you have in Arduino. I bring one example here. Suppose uh, I want to do it in the loop. Okay, int a, I define the variables, make it equal to 9. B I equal to 4, and C just I reserve and declare the variable, but it's in the form of int. Then, if I want to do the addition between A and B, simply I can do. If I want to do the subtract, if I want to do the multiplication, if I want to do the division and models, simply I can define. And you will see that it's very simple job. Then the arithmetic operator can be simply like this: a plus b, a minus b, a multiplied by b divided by b modules. If I want to do the addition 2 times, something like a variable a, which is plus 2, 1, I can even use plus plus, or if I want to do the subtraction, multiply some subtraction, I can do a minus minus. What about comparison? Comparison is also available in the Arduino. Just look to the table that I provide for you here. In this table, you can see that if I want to say something is equal to something, suppose A is equal to B, simply I can do. See here in my code. We will tell about if loop, but now you ignore this point, but just see. If I want to compare that A is exactly equal to B, simply I can use this. Or if I want to say that it's not equal, I can use the mark plus equal sign, which will do the comparison operation for me. Or if I want to say that A is less than B, see the code. If I want to say that A is greater than B, if I want to say that A is less and equal to B, I can use it exactly like this, or greater than equal. You will see that it's very simple. It's exactly like the C language. Then what about Boolean operator? It's also simple. We had 3 main Boolean operator syntax or operator. That one is AND, which we can use this symbol. One is OR and NOT. Simple. Here, suppose in this code, I said that if A is greater than B and B is B is less than A, then something happened. Or suppose I want to say that if A is equal to B or B is less than A, then you will see the or operators that we have done here. And suppose if I want to say that A equal to B and B is less than A, again, but we have one not here. Okay, if the first statement, the not for all we want, we should use this part. I can say that you will use especially and or. Rarely we will use not, but in some case you can use it. This table is very good, and it's simple. It's not much more difficult in my point of view. You can use it simple. Then the full logical relation in the C language we have there: equal, not equal, greater, less, less than equal, greater, equal, and or and not, which I tell you. These are from C language, and previous table that I show you is specifically used for the Boolean in the Arduino, which already you see. What about others? Suppose if I want to use the XOR, you should use this symbol. Binary ones, it means that the complement, you can use this one. If you want to have the shift left or shift right, you can use these two operator also. It means that bitwise operator we have, but again, I should tell you that rarely you will use, but the probability to use them is more in programming that we have. Then let us see the example of bitwise operator. Suppose and simply I use A and B, or XOR, not shift left and shift right. See, very simple, very neat and beautiful. You can use this coding term. What about compound operators? Something like increment, decrement, compound addition, compound subtraction, compound division, compound model, compound bitwise, and compound uh, like this. You will use, but not, I can say, these are the statements that even if you forget them, no problem. You can use it from and do little bit search on the Google and use the code. But if you want to see, it's like this. Myself didn't suppose use compound bitwise or compound division also rarely I use. But increment and decrement is very useful. Okay. Or compound addition, suppose you can use. But anyway, these are some other syntax also that you can use them. They are not limited to these. But anyway, it's good for you to know and see the sample for this compound operator. Okay. Then we can say that the operator in C is like this: equal, and also subtract and multiply and divide and modules and also shift right, left, bitwise, and bitwise exclusive or and bitwise inclusive or for that. Okay, then come back, see how to define the variables in Arduino. Very simple. First, we will say the type, then the name, and then the value that we want. And remember one thing, in your IDE, when you type the variables, if you type it proper, you will see that the color of syntax will change. I will show you later or when we have some real-time practicing with IDE. You will see that if the syntax is correct, then you should have different color for the entered text. Remember this point, please. Let us review one program. Okay, suppose I have this program. Let us see. First line, what I have done, I have one variable which name is delay time. This variable is in integer, the value is 2000. Okay, another variable which is green LED, the value is 9, it's in integer. Okay, void setup as the foundation of my program. It has the pin mode which wants to specify the green LED value. Green LED value is equal to 9. It means that pin number 9, and as its statement is pin mode, then the output should be the mode should be output. Next is void loop. Okay, let us see. I use the syntax as the digital write, then I specify the pin number 9, which I call it green LED. I put it here. Okay, what should I write for this pin? I should make it high. Okay, make it high. And then delay. I want to have some delay in my program. How much should be this value? This value is equal to delay time, 2000. Okay, next line. Digital write for which pin? Pin number 9, which I call it green LED. What should I do with that? You should make it low. And then what should I do? Again, I have some delay. How much is that delay? 2000. Like this, if you want to change the delay in once for all your program, you should just change that number. It may happen that suppose you have the long program that you use the value of delay in various parts and you don't want to change one by one. You just want to assign the number at the first and then finish. This job is good. This calling and using the variables will help you to reduce the load from your side. Okay, go ahead. Let us see one more program. Suppose I have that variables, delay and green line. I define them. But here I'm going to, I think little bit this slide should change because, yes, let me again, yeah, now. Again, I will share it for you. The line was little bit not, visibility was less. Okay, now you will see. Yes, that high going to the second line. I didn't want to give you the wrong address for coding. See that in digital right, I call the pin number 9, which I call it green LED, make it high. Okay, delay, I know the value 2000. Again, digital right, pin number 9, put it low. Now, the delay new definition or delay time new definition is that whatever I had before, I should minus to 100 and then put the new value there. It means that first round it's 2000. Next time it's 2000 minus 100. Again, it's 2000 minus 200 till the time it's become 0. Then what will happen when it's become 0? It should continuously turn on. Then what we expect that these become high and then at the final stage it's become suppose 0, then it's become low and then it's become 0, and then this program has some problem. It should have some if loop, but anyway, at the end you will not see what will happen. The LED will go on with very fast and then it's not blinking. It's continuously on, or maybe some continuously it will be off. Then that was some example for us to see how to use the variable. Can we do the comparison? We say yes. We can have greater than, greater or equal, less than equal, less, equal, not equal in Arduino board. And we also show the sample code. For the program or any programming, we need to control the flow, conditional construct, and also loops that we have in the C language. Suppose flow control, we can use the if else, for, while, do while, nesting loop, and switch. All are available in Arduino. Suppose if a statement, which is just check if whatever we want was available, then we will do that job. If else is that if that condition was not available, it will do another job. If else if is that it will check in some steps, and switch case is that it will compare the case and then do the job. And conditional operator, let us check first one. If my statement was there, I will do something and I will check the true false of my condition. If else if is like this: if condition 1 is available, I will do statement 1, else I will do the condition 2 and I will do the job 2, else I will do the statement number 3. Very simple, and it's exactly like the C language. See, this is suppose what we have done with the Arduino or here. Here, I will teach you this thing. This is serial communicating. But if you see here, I will check. If counter is less than 10, I will print something. Else, I will add the counter. Next is if else, as I said, is that it will compare and check the true or false condition of the statement. If that was true, it will do. Else, it will do another job. Let us check with Arduino. If counter was less than 10, it will print. Else, it will print another number. And then it will do the counter plus something again. Okay. What about Boolean operator? And as we say, suppose if I want to check the value is greater than 10 and value is less than 20, okay, I can use simply this statement. Or same, the you see the just operator. And what about switch statement, which is very nice and a strong control flow of program checker for us. It's also simple. In that, you will check the switch variable. In the case value 1, statement 1 and break. Case value 2, statement 2 and break, and some default. Statement number 3 and break. This is exactly like C language. See, uh, also while also we have. While we have condition, we have that statement, and do also and do while, which is like the C language. I have one example with Arduino. I think after these slides, we have it. It's in this lecture. I will show you. What about 4? 4 is also like this. Suppose here I written if 4 n is equal to 0 and n is less than 100, I can do the increment for the n and do something. Okay, some loop like this. I can. It's like this. The initial value and the condition and change. I can even do the n minus minus, but now our job is that we want to do the increment. What about function? Yes, it's available in Arduino. You can using the function, and we can structure our programs in a more modular way. A function is a group of statements that is executed when it's called from some points of the program. And the following is its format. It can have the type name, parameter 1, parameter 2, and so on, some statement. I think it's better to see this function in the Arduino part, but uh, because this is for the C, and it will help you more in that part. Suppose in the C language, when I'm going to specify the function, I have some int which is equal to the void part, and this is the name of my function, and then variable which I'm going to enter inside my function is shown here, and I can use it. Suppose for the loop, I can also call the function. This is the one loops, 3 variables, and this is the name of function that I'm going to call and use it. For example, this is the good example for function that I was searching for. See, I define 3 variables, I, j, and k. I give the value of 2 and 3. And then meanwhile of my loop program, I define k is going to read the function, my multiply function, I and j. Means that I and j, which declared globally, will go to function, and after loop, I return my routine or my parts for the function, which in that I'm waiting for x and y as the input. And here, what I will do, I define the variable result, which in that we should multiply x and y and then return the result. Then this result will come and then with the form of k, because the output of k is here, and then will be print. Another example, suppose I'm going to read some sensors value, and the function name is sval. Then through this sval, I'm going to read the analog value and then print them like this. This working with function is not difficult. You can simply do it, and even when we teach you the interrupt, exactly we will see the usage and performance of this function. Next point, which is important in Arduino, is array, which is the collection of the variables that are accessed with an index number. Array in C programming, um, as we review each other uh, in the C language, a sketch of the Arduino, it's also you can use it somehow with some complicated form. But some simple array we have in Arduino. I'm not agree with this sentence of the reference that I use because using the array is not that much difficult. But somehow they think that okay, using the array in Arduino it's not that much simple. You will see. Suppose this is one array. It's not difficult. What I use, I say that int my ins with the six number, or int my pins, one array which have the pin number 2, 4, 8, 3, and 6. Or int my sensors value, which it has the 6 member, and then I specify the number. Or char message, which contain the 6 member, and it's I define the value of hello for that. You can declarate an array without initializing it as my int, something like this. Means that you can have general form of array. You can declarate the value, but not specify the size. You can specify the size and declarate the value. You can change it to the char with a specific numbers. That hello, it has the 6 member, and then put it there. I don't think this is difficult, and mainly this array will help when you use the 7-segment programming or 7-segment yes hardware. When you want to program it, it will help you more. How I can access my array? It's also like C language. Suppose we will say my sense val 0. We'll put it to equal 2. If I want to call it, just I will mention the order of member inside of my array number. Suppose number 1 it's equal to 4 and number 0 is equal to 2, the array that is defined before, and you can see writing to the random memory allocation is definitely it's not the good idea and can often lead to have the terrible result for you. Even sometimes it will make a crash on your program. And unlike the suppose language like Basic and Java, in C compiler does not checking to see if array access is within the legal bounds or array size that you have declared. And this problem maybe limit you when you work with even the Arduino because you have the limited memory allocation. If you remember, we talked about this malloc in the C language. The point that I'm going to tell you is related to that lectures that we have. But to assign the value to the array, you can simply use this form, and suppose for the for loops also and calling them, you can have this simple job. If you see this, the sample that I use here, suppose for byte I which is equal to 0 and is less than 5, I'm going to add the I, and simply I can go and read my array name is suppose is my pin. Till pin number 4 I can easily read. Maybe this sample code or these parts will help you later more when you are going to do the programming in Anyway, um, maybe some of you forget the definition of the array. Again, I'll polish it with limited time that we have. You remember that suppose we have the array name of 4 and it has the 4 or 5 elements because it starts from 0, and then you can assign the number to that, you can call the members. Simply you can do. We review these parts in the C language with the one-dimensional, but with the multi-dimensional also we can use in Arduino. And same as C language, you can say the columns and rows of your array and you call it. This part, an example for this, mainly we will review when we work with the 7-segment part. Just I want that you have it in your mind. Later we should talk more about it. Okay, summarize what I tell you about the array. If I want to initialize the array with the string, simply I can use this sample char, suppose as the temps, and then put whatever I want. If I want to give the value for ntemp array, I will put like this. If I want to put the letters, separate letters, simply I can use, and double dimension also I can have. This slide is the summary of whatever I tell you about the array, because already you are familiar with the concept of that in C language. But a big but. We have the pointer, which is mainly in C language, is also difficult, but in Arduino, rarely I saw and rarely people will use. I think this part for the pointer um, will not much more useful uh, for the level that we are. I will put it in the PPT of the lectures. You can read it, and mainly these are rely on the Arduino part. Please give me sometimes about this pointer that mainly I will talk in the LCD section of the class for you. Okay, I think we finish for today, and that was good. Let me see what I cook for you to see about the Arduino course. From today, when we have each lecture, I will show you some Arduino project. Suppose what was the top 10 in the last year, what is the top 20 from this year. Like this, we will have some demo which will help you to have the better understanding regarding the Arduino. Okay, just hold on for 1 second. Let me see that how I can share the screen for you. Okay, good. I found it. Please give me feedback. Can you see the? Can
Yes,
you
sir.
see?
Yes,
Okay,
sir.
good. Thank you, Saddam. Okay. See,
See, you can see, sir.
the main question and maybe the reason that I will show you these videos is that I remember that some years back, my student tell me that what we can do with Arduino and what we cannot do. Okay. Then I tell them that you can do various jobs. They tell me that, okay, please give some example. Then after that, I decided to just tell them that you can do this, you can do that. I show them the Leap project, and easily you can even download from YouTube. Uh, Suppose this set that I will give you, there was the top 10 project, or which have some good idea in 2020. Again, I will search day by day and maybe change them. But see, what they have done, they use one ultrasonic sensors, and I think the word should be Ono, and three actuators here to do the programming. And see, randomly they will use the game with the help of Arduino. Arduino, we just randomly turn any of scissors or stone or papers, and the act of this sensor is that whenever it's become near, just trick the Arduino. Don't think that Arduino knows what to do. Okay, randomly, exactly like that. You are going to play with your friend. It's like that. Suppose one project number 9. They use some CPU cooler or CPU loader, which based on the load of the CPU, the color for these tools or gadget that they make will be changed. These are some RGB LED, and then they just read the value by the analog read, and when the value is higher than some percentage, the color will be changed. See the load numbers that they, is it visible for you from your side?
Yes, sir.
Yes.
I think somehow seeing the other person's project will encourage you also to do the job, real job with the Arduino. At least for me, it's like this. When I will see that they have done, I see that I also can do. Some voice activated door, suppose you can do. This mother will say open, and the door will open, and then say door close, it will do. Really, they didn't do much more magic job. I can tell you that what they have done. There is a small module that they will add it to Arduino and then do. There is not very high tech job, but it's nice anyway. And also the LED figure is also changed. Project number 7 is coffee making robot arms. Yes, pick the coffee, put it in the hot water. Okay, go back, take the milk, put it there. Okay, go back, stir it. How? Like this. Take the stirrer. Yes. Now, this project is also very simple. Don't think that they put AI or something like that there. They just put the sequence for that. Okay, something which when we use in Corona time. I like it. See.
Yeah, self hand sanitizer pump.
Yeah. Maybe some of you see it because really it's become the mass product in some countries. I saw. And in some shops, even in my country, they use it. They do it with the mass product. But now you can simply do it with the Arduino. I think the maximum line for this is below 10 line. See, there is one infrared sensors, IR sensors. When it's become there, they can do the digital reading to the Arduino, and after that, just say these motors that done. Till the time that you touch this, it can do. See, as much as you become near or keep your hand near to that, there is some analog read or digital read. Any of these two can job. These can do the job. Number 5 is some robotic arm gripper that they make. and but they use the potentiometer to that. Means that all analog reading they will do. Go there and control it. Go and come back. They can go down also with the help of second potentiometer that they have. Yes, going back. Project number 4. Yeah, sound tracker mirror. If you stay for 2 minutes, we can finish these sets. I think they are interesting. Here they have the sound tracker, which in that they can transmit even light to the room. Okay. Let me make it little bit fast. Yes. How they will do? Very simple. I think the whole project is less than 100 RMB because one LDR can take the feedback and then guide that motors. Second is that the robot, okay, Bluetooth control RC cars, which in that I teach you MIT app. Some project like this we will do this semester. Be sure, okay. The module here is HC05, Arduino Uno, and L298 DC motor controllers. This is the H-bridge one. And here there is the app that all of you now can make it with the help of MIT. And just send 1, 2, 3, 4, 5. But define in Arduino, when it's received 1, it should go straight. When suppose it's received 2, it should come back, and so on. See, very simple but nice project. I like it. And you can control it. Yes. Project number 2 is a pancake machine. I like this project. This is something that Reza, maybe you like it more.
Yeah, you can say that.
Yeah. But other students don't know what I say because Reza is the good roti cooker. See.
Sir.
No, see how they will roll it. It's very nice. See? What you say in your language, Reza, you say chutney. Huh? Chutney dal laga.
That's not chutney. I don't know what is he putting, but we like beef more. Beef
Yeah, beef more. Yeah, mutton will be. Yeah. And interactive coffee table also you can make if you want to have some hobby in your house. Some RGB LEDs and like this, and some magnet sensors can be. See, when they will move with the magnet sensors, they can sense the place and just turn on that location's LED. It's not magic, huh? See, it's not magic. It just can be some sensor. See, here you will see. This IR sensor is there. By the reflect of that IR sensor or some type of magnet sensors, they can do. It's not magic, and it's very simple. How many lines for Arduino we can do this project? Whole project less than 4 lines. I trust. 4 line Arduino. This must night job. See? It's great. Kaya maybe like these jobs also.
Definitely, sir.
Okay, yes. Anyway, I think it's okay for today. Each section and each lecture, we will review the project like this. Then the main skill that you should take in this course is that it's because this is embedded design. I should tell you some sensors. I should tell you some concept of the other project with some controller that with this method I will try to do it. Okay, very fast, please turn on your camera that we can do the attendance.
Sir, I'm on.
I can see Jose. I can see.
Yeah, SK, I can see that you are sleeping.
I think they were asleep, Reza. And I don't know what should I do with the sleepy students in the online course. Roy, I cannot see you. Ronak, Mala, come on. Azmin Iqbal, fast. Fast, fast, fast. Okay. Send this attendance to the school and we can say that today's job is finished. What is your task? I will not put it on the MOOC system, but you should install the Arduino IDE on your PC. Okay, please follow the PPT that I put, and even you can review the movie that we will share on the MOOC system. Just go to Arduino CCE, software, download, and run it. Okay. Like that, if you install it for the next section, we will start to do the real programming with the LEDs, and you should prepare for that. Okay? Any question?
Yes, sir. No, sir.
No
Any
questions.
question? No question? Okay. Please, you left the group because I should do the attendance and send the text. Okay, thank you. See you. I will be there, but you should left.
Okay, sir.
But Roy, you remain. I want your help. Roy, remain. All of you, please left. Roy, can you hear me? Ronak, Mala, please left. Jahid, please, you also left. Hello, Roy. Where are you? Okay. See, I want to take that sheets for the attendance, but it's not coming. For the setting is not there. And where was that list?